Hello friends, welcome back to my YouTube channel. This is Ramdas Pandit Bharsat, working as Assistant Professor in Chemistry at Maratha Vidyaprasar Samaj, Nasik. In this video lecture, we are going to see about the buffer solution. First of all, we should know where we can use the buffer solution. Some reactions are occur at a specific pH. So that to control the pH we can use the buffer solution. You will see in some kind of titration we are using a buffer solution because of that reactions are occur at only and only specific pH. That's why we are using the buffer solution. So what is my buffer? That is we are going to see and what are the types of buffer solutions. Okay, how we can prepare it. What are the solutions are present in that solution that we have to see in this video lecture. Okay, now buffer solution, the definition is you will see that an aqueous solution which resists a change in pH on addition of small amounts of an acid or a base is called as buffer solution. So you can simply say by addition of this small amount of solution we can control the pH of the any kind of solution. Okay, now you will see buffer solutions are prepared by mixing of two solutions in a such a way that they contains two species of a conjugate acid and base pair. Okay, so two different solutions we can mix together. After that you will get the buffer solution, and that two species will be conjugate acid base pair. Okay, and buffer solutions are generally two types. That the first one is acidic buffer and second one is basic buffer. And you can simply say here the acid buffer pH will be less than 7 and basic buffer pH will be greater than 7. Okay, now we have to see the detail about both of them. First of all we have to take acidic buffer. So simply say we have know that the solutions which maintain the pH values less than 7. If we want to control the pH less than 7, so we can use that times the acidic buffer solution. If you want to control the pH greater than 7, so you can simply use their basic solution or basic buffer solution. They are made by mixing an aqueous solution of weak acid. Okay, how we can prepare the acidic buffer solution? The mixture of weak acid with a solution of its salt with a strong base. So in this way you will prepare the salt of weak acid. You will take CH3COOH weak acid and the strong base, so you will get the salt of weak acid. Okay, and mixture of this is salt of weak acid and the acidic acid, that will be the acidic buffer solution. Okay, now how will you prepare the salt of weak acid? In this way you will take acetic acid plus NaOH is the strong base, so it will extract the H plus from this acidic acid here. Okay, there. So in this way you will get salt of weak acid and side product is the water. So you will see the acidic acid, it dissociate like this: CH3COO minus plus H plus. Okay, so acidic acid is the acid, so obviously it will give the H plus to the another species. So before giving the H plus, it will dissociate first like this and then it will give the H plus to the another species. Weak acid equilibrium lies to the left, and here salt will form Okay, Na you will see here CH3COO minus plus Na plus. Okay, so this also dissociate in this way. Soluble salt fully dissociated in the solution. Okay, so if you will take the salt CH3COO, so that will be dissociate in this way. Okay, that means if you will add the acid, okay, in the conjugate base, so it will form the undissociated molecules, that will be CH3COOH. You will see the addition of H plus combines with the conjugate base, okay, and will form acetic acid. So reaction will be like this: conjugate base CH3COO minus, okay, plus addition of acid, okay, acid will give the H plus, okay, so it will combine in this way CH3COOH. Okay, if you will add the base with the acetic acid to form the CH3COO minus and water, okay, you will see the reaction acetic acid plus addition of the base and will form here water in liquid form, and here CH3COO minus. Okay, here will be base. It will abstract the H plus from the acid, and that acid will give H plus to the base. Okay, so here will be water and H plus will go from here, so here will be the minus sign. In this way the reaction will be there. So in this way, if you will add the acidic buffer solution in a specific solution, so like this reaction you will see in that. Okay, now we have to see about the basic buffer. Okay, now in this case we have no, it will be the pH will be greater than 7. The solutions which maintain the pH value greater than 7, and they are made by mixing an aqueous solution of weak base with solution of its salt with a strong acid. So you will see the mixture of weak base, that will be the NH3 in an aqueous form, and NH4Cl, okay, that is the salt of weak base with a strong acid. If you will take that NH3 with the acid, so you will get NH4Cl salt. This is the salt formed by the mixture of HCl and NH3. Now you will see the buffer solution, how it will form. The dissociation will be here, okay, after the combination NH3 plus water is here, okay, in liquid form. So here will be NH4 plus and NH3, it is a acting as a base here, and water is acting as a acid here, so that water will H plus will give to the NH3, so here will be the NH4 plus, it will be aqueous form. Here will be one hydrogen will be lost here, so OH minus only here. So water is acting as here acid, it will give the H plus ions to the NH3. So reaction will be like this. The weak base equilibrium lies to the left here, okay. So after the formation of salt, you will see NH4Cl in aqueous form, it will dissociate completely NH4 plus and Cl minus, okay. So in this way it will dissociate completely, soluble salt fully dissociated in the solution. So when you add the acid, okay, or H plus ions with the base, so it will abstract the H plus ions from the acid, okay, and it will form the NH4 plus. You will see here will be 3 hydrogen and here are 4 hydrogens, okay. So addition of H plus you will see addition of H plus here is okay, and it will form NH4 plus. So in this way reaction will be occur, NH3 plus H plus, which is will get form acid, okay, and here will be product NH4 plus. And if you add the base combined with the conjugate acid, it will form NH3 and water here, okay. OH minus combined with the conjugate acid, you will see the reaction NH4 plus and addition of base here, okay. OH minus, you will see it is the base, and it will form the water in liquid form and NH3. So in this way, if you will add the buffer solution in a specific solution, so like this reaction you will see at times. So this is the mechanism. If you will add the acidic buffer solution, and if you will add the buffer basic buffer solution, so like this mechanism you will see after the addition of both this kind of solution. Now we have to see about the Henderson's Hassel balance equation of buffer solution. Now consider an acidic buffer containing equimolar mixtures of weak acid, that is HA, and its salt Na. In aqueous solution they dissociate as in this way. Ha, okay, they will dissociate H plus aqueous in form plus A minus, okay. Now weak base equilibrium lies to the left due to the common ion effect. Hence the concentration of Ha is equals to the concentration of acid will be there, okay. The concentration of Ha is equals to the concentration of acid, okay. Common ion effect, because of the common ion effect. And after that you will see the dissociation of that salt. Na will dissociate Na plus in aqueous form plus A minus. It will completely dissociate in aqueous solution. Now applying the law at equilibrium equation, that equation, okay. So you will get Ka, dissociation constant for the acetic acid, okay. You will get the concentration of H plus, the concentration of A minus, that is the product, the concentration of product divided by the concentration of reactant. Here will be the concentration of Ha. So we are applying the law of equilibrium equation for this equation. So you will get the concentration of A minus is equals to Na, concentration of Na is equals to the concentration of salt, okay. Now you will see the salt is completely dissociated here, so you will get the equation in this way. Ka is equals to in bracket H plus, okay, in bracket Na and A capital. So the concentration of H plus and the concentration of Na and divided by the concentration of Ha. You will get after that the concentration of H plus and the concentration of salt divided by the concentration of acid, okay. Just you have written in the word manner here. This is salt, okay, salt we have written here salt. This is the acid, and H plus we have written as it is. So we have to arrange that equation in this way, okay. Just we have arranged here that H plus will go here, okay, and Ka will be go here, right hand side, okay, and this concentration of H plus will go at the left hand side. So we will write simply the concentration of acid divided by the concentration of salt. Now taking negative logarithm of the both side equation, you will get in this way minus log in bracket H plus is equals to minus log Ka minus log concentration of acid divided by the concentration of salt, in bracket acid in bracket divided by in bracket salt. So you will get this equation for the acidic buffer. Okay, pH is equals to pKa plus log, okay, the concentration of salt divided by the concentration of acid. So this is for the acidic buffer. So this equation is known as Henderson's Hassel balance equation of acidic buffer, used to calculate the pH of acidic buffer solution. Okay, if you want to calculate the pH, so you can use this equation. Similarly, to calculate the pOH of basic buffer, the Henderson's Hassel balance equation is as like this. You will see the pOH is equals to pKb here. Okay, here will be the pKa for the acid and here pKb for the base, plus log the concentration of salt divided by the concentration of acid. So this is for the basic buffer. Okay, Henderson's Hassel balance equation for the basic buffer. Okay.